Okay, I'm going to solve systems of equations in a different way this time. First, we just learned how to solve systems of equations using the equal values method. Now I'm going to solve systems of equations using the substitution method. Okay, so I'm going to use substitution to solve these problems. And remember, when I solve a system of equations, if I have two lines and those lines are on the graph that look like this, this is my y or my x-axis, excuse me. If this is my x-axis and this is my y-axis, and I have two lines. If I have a line that goes like this and I have another line that goes like this, when I solve a system of equations, I find out where those two lines cross. So I'm trying to find that point when I solve a system of equations. So if I'm doing this problem, let's start off with another one. I used the equal values method before, and the equal values method works really well if I have an equation like y is equal to one thing and y is equal to another thing. Well, let's try, let me give you another example. I might have something like x plus y is equal to 15 and y is equal to 2x minus 3. Okay? Now this one doesn't set up, I could use the equal values method if I wanted to, and I could subtract x from both sides and then use the equal values method for this problem. But there's another way to solve problems besides the equal values method. There's actually a couple ways, and that's the way we're going to work on today is substitution. So if I know y is the same as 2x minus 3, and I know that x plus y is equal to 15, what I'm going to do is I'm going to replace this y with 2x minus 3, and I can do that because y is the same as 2x minus 3. So if I write this equation over and replace the y with 2x minus 3, I'm going to have x plus 2x minus 3 is equal to 15. Okay? Now I just have one equation with one variable. And if I have one equation with one variable, I can always solve for that variable. So when I do it, let's go ahead and do it. And first thing I have to do is combine my terms that are alike. I have an x and a 2x. Well, x and 2x is 3x, but I still have that minus 3, and that's equal to 15. And then if I add 3 to both sides, I have 3x is equal to 18. Then I can divide both sides by 3, and I get x is equal to 6. So my value where these two lines cross, x is going to have a value of 6. But I have to find out what the y value is at that point. So what I can do is I can put in x equals 6 into either of my two original equations, either this one or that one. And I should get the same answer. So let's put it in the second equation first. So I know y is equal to 2, but instead of x, I'm going to put 6 because that's what x is equal to. So 2 times 6 minus 3, which is 12 minus 3, which is 9. So the point of intersection is 6, 9. My value of x is 6. My value of y is 9. Now just to make sure that I did that correctly, let's put 6 into my other equation for x. So instead of x, the equation is x plus y is equal to 15. But instead of x, I know it's 6. So 6 plus y is equal to 15. I can subtract 6 from each side. And I get y is equal to 9 there too. So I know my point of intersection is 6, 9, no matter what point I pick. So these two lines will cross at x equals 6 and y equals 9. Okay? I'm going to give you another one, and I'm going to have you see if you can do this next one. So the next problem I'm going to do is this one. We'll try one of the equations is y is equal to x minus 5, and the other equation is 2y minus x is equal to negative 2. So I want you to pause the recording, and what you're going to have to do is substitute y into this equation. So what I want you to do is go ahead and substitute the y into that equation and see if you can solve it. Okay? So I'll pause the recording and see if you can solve this using substitution. Okay, let's see how you did. So what I'm going to do is I'm going to rewrite this equation, but instead of using y, I'm going to replace y with the x minus 5. And I can do that because y is the same as x minus 5. So I'm going to write it as 2, but then instead of y, I'm going to put in parentheses x minus 5 minus x equals negative 2. Okay, if I have something like that, I have to use a distributive property first. I've got to distribute the 2 through the parentheses. So 2 times x is 2x. 2 times negative 5 is minus 10. Minus x equals negative 2. Okay, let's combine my like terms. I have a 2x and a negative x. That just makes x minus 10 is equal to negative 2. And then I'll add 10 to both sides. And I end up getting x is equal to 8. So my value for x is 8. So let's plug that in and make sure that worked. Or we'll see what value of y is. So I know that y is equal to x minus 5. So y is equal to 8 minus 5, which is equal to 3. So the point of intersection I got was 8, 3. Now let's see if that works for the other, if I put the x is equal to 8 into the other equation. Okay? So if I do that, I have a little bit more difficult math, but I can still do that. I'll say that 2y minus 8 is equal to negative 2. So I'll add 8 to both sides. And I get 2y is equal to 6. Divide by 2. And I get y is equal to 3 that way also. So no matter which point I picked, I'm going to get y is equal to 3. So the point of intersection for that one is 8, 3. Okay, I'm going to have you try one more on your own, and we'll see if you can do this one. The last one we're going to try, the two equations are x equals 3 minus y, and 2x minus y equals negative 9. So what I want you to do now is pause the recording and try and solve this. Remember, after you plug in x is equal to 3 minus y and solve for y, you'll have to use that y to get your x value again. So you have to get both points. You have to know what both x and y are to find the point of intersection. So go ahead and pause the recording and see if you can do this. Okay, let's see how you did. So in this case, I know x is the same as 3 minus y. So what I'm going to do is I'm going to use that. I'm going to replace x in my other equation with 3 minus y. So my new equation, I'm going to have one variable. I'm going to have 2 times, but instead of using x, I use 3 minus y is equal to negative 9. 2 times 3 is 6. 2 times negative y is negative 2y minus y equals negative 9. If I combine my like terms, I have negative 2y and negative y. That makes negative 3y plus the 6 is equal to negative 9. Now I need to get y on one side because I got to solve for my variable. So I'll subtract 6 from both sides. And I get negative 3y is equal to negative 15. Now I have to undo multiplying y by negative 3 by dividing both sides by negative 3. And I get y is equal to 5. So the equation I have is y is equal to 5. Now I've got to solve for x, and I do that, I'll be all set. So let's put it into, this one looks like it's the easiest one. So let's put it into that equation. So I know that x is equal to 3 minus y, but y is really 5, so it's really equal to 3 minus 5, which is equal to negative 2. So my point of intersection is x of negative 2 and y of 5. Now to make sure I did that right, let's put 5 into that equation also. So I'm going to do that right up here. I have 2x minus y is equal to negative 9. And then I'll have 2x minus 5 is equal to negative 9. I'll add 5 to both sides. I have 2x is equal to negative 4. And if I divide both sides by 2, I get x is equal to negative 2 there too. So either point I used, I get the point of negative 2, 5 as a point of intersection. And that's how you solve a system of equations using substitution.